All right, Matsu, here we go. Lesson 11.2.2, surface area and volume of a cone. We're going to calculate the volume of pyramids just as a review of what we've done before. So for this one, we have found out that the volume is 1/3 the base area times the height. Okay, so let's go ahead and look at this one. Looks like we've got a square pyramid that's oblique. So we're going to do 1/2 volume equals 1/3. I almost said half. The base area, here's my base. It's a rectangle. So I'm going to do 6 times 4. 6 times 14. Wow. My height, remember the height is perpendicular to the base. So my height is over here on the side. It's just oblique. It's just been shifted over. So that's 19. Let's see, 1/3 to, I think that gets you 28. So 6 times 14 is 84. And then 1/3 of 84 is 28, like I thought. And 28 times 19 ends up being a volume of 532 units cubed. All right, next one, we've got a hexagonal pyramid. So we need to find the base area first. So let's see, got to get our apothem and everything. And we've done enough hexagons. Hopefully we remember that this is 30 because you do 360 divided by 6, and then the apothem cuts it in half. So this is just this section right here. So this is 5. So it looks like our apothem, since this is a 30, 60, 90 triangle, this is the A side, the apothem is A√3. That's 5√3 right there. So the base area for a hexagon, so we got 1/3. The base area is 1/2 the base of 10 times the apothem of 5√3 times the number of sides of 6. So there's my base area. So this is all the base area. And then we have a height. Ooh, I don't know the height. Oh, no, I do. This is outside. So for a second there, I thought that they were giving us a slant height. So the height is out here. It's the perpendicular height to the base, 36. All right, 1/2 of 10 is 5. 5 times 5 is 25. 25 times 6 is 150. So there's the base area. So 1/3 of 150 is 50. And 50 times 36, 1,800. So we get a volume of 1,800√3 units squared, cubed, not squared. That's the exact answer. If we wanted to find out what that was approximately, the approximate answer ends up being about 3,118 units cubed. Next one, this is a triangular prism. Here they say that we have a 90-degree angle over here. So this is the base down here, and this is the base and the height of that base. So our volume would be 1/3. The base area is a triangle, so that's 1/2 of base times height. And then the height is over here because it's perpendicular to the base. So the height is 13. So the base area, 1/2 of 4 is 2. 2 times 9 is 18. A third of 18 is 6. And 6 times 13 is 78. All right, how can we find the volume of a cone based off of our investigations into a pyramid? So a cone meets at one point very similarly to a pyramid. Our height is still inside the shape. And this would be our slant height over there. And this would be our radius. So we said before, we could imagine, well, with a pyramid, we imagined a prism being on the outside, like this over here. So for a cone, we would imagine a cylinder being there. So for this one, when we're looking at the volume of a cone, since a pyramid is 1/3 the prism, we would probably assume that the cone is 1/3 the volume of a cylinder. And the cylinder, the base area was pi r squared, and then times the height. So we would probably have 1/3 pi r squared times the height, because we're finding out that when we meet at one point, we lose 2/3 of our volume and we keep 1/3 of our volume. So looking at this one, finding the volume of this cone, looks like this is the height of 12. It looks like it has a radius of 8. So our formula would be 1/3 pi r squared. So pi times 8 squared. So that's the base area. And then multiply by the height. And the height is 12. So this is 1/3 of 64 pi times 12. So I can take 1/3 of 12 instead of 1/3 of 64 because 3 doesn't go in there. So 12 divided by 3 is 4. And then 4 times 64 is 256? 256. And that being cubic millimeters. Now that's the exact answer, but if I wanted a approximate answer, I'd have to use my calculator and find out when I do 256 times pi, I get approximately 804 millimeters cubed. All right, James wasn't paying attention and his ice cream melted. Oh, silly James. Filling it up to the top of the cone. Find the volume of the ice cream and the surface area of the cone. Okay, so it looks like we have a diameter of 4, so our radius is 2. But here, we've got a problem. We know the slant height over here of the cone is 6. So we would need the Pythagorean theorem in order to find the actual height of the cone. So we would do 2 squared plus the height squared equals 6 squared. So this is 4 plus 8 squared equals 36. Subtract 4, 8 squared equals 32. Square root both sides, h equals the square root of 32, which is 16 times 2 or 4 root 2. That's his height. So we used the Pythagorean theorem to find the height because we were given the slant height. Okay, so now we're ready to find the volume of this. So the volume of the cone is going to be 1/3 the base area. So the radius was 2. So this would be pi times 2 squared times the height. And we just found out the height was 4 root 2. We can just leave it as root 32. And let's do it as 4 root 2 just for fun. 4 root 2. All right, so we've got volume equals 1/3. This is 4 pi times 4 root 2. This is really looking ugly. Multiply going straight across on top. And we get 4 times 4 is 16 pi root 2 all over 3. That's the exact answer for the volume. We would probably not want to leave it like this. So, oh, and that's in inches. So I would plug this into my calculator. 16 pi root 2 divided by 3 comes out to approximately 23.7. So I just did 16 pi times root 2 and then divided by 3. It gave me 23.7. And now we get to the interesting point. We want to find the surface area of this cone. Now the surface area of the cone, this actual cone doesn't have a top to it. So we want to find out, how much is actually the cone part that we would eat. So we're only going to be looking at our lateral area. Normally a surface area would include this circle up on top, but that circle's empty and we're just looking for how much is on the cone there. So the lateral area of the cone, if I took this cone and pulled it apart, so here's the cone and I pulled it apart, I would end up, if I cut this cone down along this side, it would make this kind of shape, where over here, this side right here is 6, and that's the lateral height. Okay, and then so the lateral height is kind of the radius of this one. We don't know what the angle is here. So what we have is a sector. And over here, we actually do know how much this section is. That's the whole circumference of the cone, 2 pi r, or 4 pi. So we know that in a sector, we do the number of degrees over 360 times pi r squared. That's what we would normally do for a sector. So for this one, what we're going to do instead is we're going to find a formula that we can use to find this section without having to find out how many degrees this angle is right here. So here we go. So this section right here, that is this is a length of the sector right there. That is 2 times pi times the radius. Now the radius is actually this L, this lateral height. Okay, so that's how long this section is. Now what we actually got was 2 pi r over here. So this section here is 2 pi times the actual radius. So the whole thing is 2 pi r, and this section is 2 pi times the radius. So this is our ratio of the angle compared to 360. 2 pi r over 2 pi times the slant. And then we would normally do for the whole area of the entire circle, that would be pi times r squared. R is the slant height. I know this is going to lose like half of you, but we're coming up with a formula here. So this is the ratio of degrees over 360. Luckily, these reduce. And then over here, one of these slant heights is reducing with one of these slant heights, and we now have a formula for this area. My final formula, all I have left is r, pi, and the slant height. And that is the formula for the surface area. Now remember, we're only doing the cone part, not the circle on top. So it's r times pi times the slant area. So r is 2, pi, and the slant area, or slant height of 6. So our surface area is 12 pi. And if you use a calculator, 12 pi is approximately 37.7. I know I went over a lot of people's heads with that. So let's just write down our formula in our, what was it called? The graphic organizer over here. So we started this graphic organizer on the last lesson. Let's look at the volume of a cone. It's going to be 1/3 base area, which is pi r squared, times the height. So we've got a cone. Here's r. Here's the height. Here's the slant area. For the surface area, we have a circle on the bottom. That's part of our surface, so that's pi r squared. In that last example, we didn't use it because that's not actually part of the cone you eat, that's just an open section. And then plus this lateral area over here, and we devised a formula for it, and that was the radius times pi times the slant height over there. I know I lost you on this one, so let's just stick with this as the formula for that one. It's a little much to devise that formula. Anyways, that's all I got for you guys today. Math hard. See you guys later. Bye.